Welcome everyone. I hope you are able to hear me. A quick confirmation from anyone and then we can get started. Are you able to hear me? Okay. And let me see if my sound is okay because again, as I mentioned, sometimes I create problems because of Zoom. Let me see this audio. Yep, it's perfect. Now, welcome everyone to this session. And in this session, we will be talking about AI in telecom, AI ML in telecom, right? So what is AI ML? How do we really use it? What are the different use cases in telecommunication? That's what we're going to discuss, right? So in this particular discussion, we will talk about overview to AI ML in telecom. What are the network architectures which are evolving with the use of AI ML? What are the different AI ML use cases in the 5G and related network? And then overview to key concepts of AI, ML, DL, generative AI, etc. in the telecom world. Please note, this is a introduction session for our paid course, and I will be talking about the details of the paid course by the end of the session. If you're not interested in that paid session, please feel free to drop out at that point of time. Right. Now, let us talk about AI ML in 5G and beyond. And even before we talk about it, first of all, the AI ML is not really new to the world and not even new to the telecom, right? Starting from 2010, where we started talking about SON or self-organizing network, AI/ML has been a main ingredient in managing the network. But where exactly we need where we need AI/ML, that is something what we need to understand before we actually start jumping on the bandwagon of AI/ML into the telecom world. Right. Now, if we look at the overall use cases of AI/ML in telecom, the very first and the primary use case of AI/ML in telecom is going to be related to network management. And that was the first thing which got implemented into the wireless network for managing the networks, right? And then we can also use it for optimizing these networks. We can also use these things related to service assurance and improving user experience in terms of QoE prediction. So we have actually some kind of use cases where we predict the quality of experience for the user, which can help us to enhance the user experience. We can also create a lot of predictive and data-driven insight by using these tools into the telecom network and also building some newer use cases related to the end user, which can also help operators to create some new revenue streams for the network. We all know that the telecom networks are actually getting very big capex for the companies and generating and the subscribe the revenue streams are shrinking. So generating new revenue streams for the operator is going to give a new lifeline to the operators. But how it all started, how we actually started moving into the direction of AI/ML, right? So first of all, the earliest standardized model for the telecom network management was called as TMN model, which is typically comes with 5 layers, which are referred here: business management, service management, network management, element management, as well as the network element layer. But it also comes with 5 functions, which are shown in the right side of it. And we will be talking about all these different functions in the next slide. So basically, the TMN model was the first standardized architecture for managing the telecom network. But what is FCAPS? What is FCAPS? Fault management, configuration management, accounting management, performance management, and security management. So what FCAPS takes care of it? It typically takes care of the faults whenever there are any software, hardware, and connectivity related fault in the network. It will take care of it. The configuration, when we have some configurations to be changed, updated in the wireless network. Accounting, who is doing what and keeping everything in check. That's what accounting takes care of it. Performance of the network, how the networks are performing or do I use all the resources available in the network efficiently? And last but not the least, the security part of it. Right. However, when we talk about AI/ML, of course, AI/ML has a role to play in almost all these five functions, but most of our discussion will be either around fault management or configuration management or even the performance management as well. Right. Now, if I talk about the future evolution of TMN, TMN got evolved into something called as TOM, Telecom Operations Map, which further evolved into something called as ETOM or Enhanced Telecom Operations Map. And the picture what you see in the right side is a picture related to the ETOM, which is one of the component in the NG-OSS framework, next generation OSS framework. However, we are not going to talk about it. What is NG-OSS, what is ETOM in our session, but this is how it evolved over a period of time. But till this time, most of the processes were manual processes. Most of the processes were manual processes. And somewhere between 2008 to 2010, networks started, increasing exponentially. The number of nodes, number of devices in the network started increasing exponentially. And that's where managing all these networks manually became difficult day by day. And that's where we brought in some concepts like SON, self-organizing network. So the self-organizing network typically talks about, and if you look at the core of SON, which is completely based on AI/ML. So completely machine learning based configurations where machines are automatically learning by themselves and taking these actions. So self-healing takes care of the fault management part of it. Self-configuring takes care of the configuration management, and self-optimizing takes care of the P part of it. So if you see F, C, P, these are the things which are actually driving the major use cases related to self-organizing network. So in fault management, you can actually do the check the failure, neighborhood localization, outage, power related things, and self-learning where network can learn themselves based on the network, subscriber, and location. In the configuration part of it, it can actually estimate the coverage of the cell deployment, authentication, system update, parameter adjustments, etc. And in the performance optimization, it can take care of the quality optimization, coverage, capacity, bandwidth, interface, or handover optimization. So most of these KPIs can be improved. Most of these KPI can be improved by using some machine learning techniques in the self-organizing network. Now, one second. Okay. Now, if you look at 5G and AI, they are also becoming very, very complementary to each other, where 5G provides you extreme capacity, multi-Gbps speeds, and ultra high reliability and low latencies. The AI can do contextual awareness, personalization at scale. So basically, these are two different worlds coming together to give you the next level experience in the telecom network. So the advancement in AI is making 5G better. Now, the way we use 5G network, the way we use 5G resources are getting better and better day by day with the implementation of AI. And proliferation of 5G is making AI better because to make AI better, we need a lot of data. And 5G and the future network will be able to give access to a lot of data, and that will help AI to become better day by day. Right. I normally get another question here. People say that, okay, what is the difference of in AI in the 5G network and in the 6G network? I normally give them this answer with the analogy. And when I say this, what is the difference in 5G and 6G in terms of AI? I generally ask them, okay, what kind of cake you like, right? So most of us, like eating cake. But if I ask you, what is the flavor of the cake you like, right? Can you just answer this question before I tell you the difference in AI in 5G and 6G? What is the flavor of the cake you like? Can you answer that in the chat box? What is your favorite flavor for the cake? Okay, so nobody likes the cake. Okay, so rasmalai, chocolate, blueberry. Okay, we see a lot of different flavors here, right? But generally, what I see is I get the answer as a chocolate cake, right? So there are some chocolates, some blackberries, some rasmalai, and all that cakes, right? So that it's different. People have different idea. But if I talk about a chocolate-related cake, now I can create this chocolate cake in two different manner. In the first manner where I create this cake with a normal bread or with some plain vanilla flavor cake, and on top of that we can have a layer of chocolate. This is how the AI looks like in the 5G network. In 6G, the AI will be one of the main ingredient of the cake itself. So this cake itself will have the chocolate in itself. On top of that, it can also have another layer of chocolate. So this is how we are going to see the AI in the 6G. What I'm trying to convey here is in 5G, the AI is used more as a topping. 5G, it is used more as a topping, more as an add-on functionality. The 6G network is going to be AI native network. So if you look at the 6G use cases, initial IMT use cases from 6G, they also talk about one of the vertical as AI native architecture. AI native architecture, that means in each and everything what we build in 6G, AI is going to be one of the key ingredient for that particular architecture. So that's how we are differentiating the AI implementation in the 5G network and the 6G network. Let us talk about some of the recent things what we have done, in the 5G network. Okay, give me a minute. Let me see. Okay. Okay, who is this Mohit Fanse? What you are trying to do? Let me stop you from doing it. I don't know what is happening here. Just give me a second. Somebody is trying to take control. Please don't do that. This is disturbing the whole session. Right. So I don't know, how to reduce it. Okay, let it be. That's no problem. Right. So now let us talk about, if you look at the 5G core network architecture, and we just talked about this particular discussion in the previous session, we also have a new network functions, what we have not talked about in the previous session. It's called as NWDAF. NW, the network. DAF is data analytics functions. DAF is called as data analytics function. That means this is going to be the AI ML engine of your 5G core network. This is going to be the AI ML engine of your 5G core network. In addition to that, the radio network is also moving towards the openness, Open RAN architecture, which also have a lot of discussion happening around AI ML. But in addition to that, recently we have also introduced another alliance called as AIREN Alliance, which we are going to discuss later, where we are talking about AI-based radio access network. They have defined 3 different work groups, and we will be talking about it, and we will be extending it to the different use cases as well. Right. Now, if you really want to talk about the how the AI/ML model lifecycle works in the open end, this is one picture which comes from the Linux Foundation. So Ecumos, which is one of the LF project, which is used for a ML designer for the open end. However, I'm not really spending the complete time here to talk about this model, because this one picture itself is very complex. We can speak for this picture maybe 30-40 minutes. Just this one picture talks about how the AI models are designed, how they are trained, how they're deployed in the real world network, and how they are taking the real time action. So this is creating a kind of cycle from here to here, and we keep on training and retraining these models when it comes to the OpenRAN. So in our course, we actually talk about all these things pretty much in detail related to ML model lifecycle in the OpenRAN architecture. The network orchestration is one of the area where we see the maximum intervention of AI/ML, where we see the maximum intervention of the AI/ML. Now, this typically works like a central orchestrator, which is typically taking care of all the different pieces. But in addition to this, we also have lot of domain controllers related to radio network, transport network, and the core network, and they are taking care of their respective domains. So basically, this becomes like the CEO of the company, and these are the various managers handling their own department. Right? So this is typically how the network orchestration looks like. The complete orchestration scenario, right, is driven by AI/ML capabilities. Now, in this particular slide, you see a picture called as MANO, MANO. We also refer this sometimes as NFV MANO, Network Function Virtualization, Management and Network Orchestration. Can somebody guess which organization has created the framework for NFV MANO? Can you guess that in the chat box? Which organization has created the framework for NFV MANO architecture? Anyone? Can you guess that? Okay, so most of people have got the right answer. So the NFV menu architecture is created by HC. So HC is the organization which has created the NFV menu architecture. The complete framework of Mano is coming from the HC. So if you really want to know more about it, and the typical picture what we see whenever we talk about NFV is all comes from the HC architecture. It all comes from the HC as an organization. Now, let us talk about some of the key AI/ML use cases in 5G. Now, even before we talk about it, as I mentioned recently, they have talked about AIREN Alliance, a new alliance which was created, and they typically talk about three different working groups called as AI for RAN, AI on RAN, and AI and RAN. What I feel that, talking about AI/ML just from the RAN perspective may be good, but may not make great sense. What we need to do is we need to look at the holistic picture of AI, how it can be beneficial into the end-to-end telecom network. And with this, we are talking about AI not only from the RAN, but in the telecom, including the radio network, the core network, the transport network, user, and the applications. And then only it is going to make sense. Now, what is AI for telecom? What is AI on telecom? What is AI and telecom? We are going to see in the next slide. Now, AI for telecom, AI for telecom is going to leverage artificial intelligence. So basically, this is suitable for any existing use cases which can be related to resource allocation, interference management, predictive maintenance, operational efficiency, and things related to that. So all the existing use cases will be coming under the category of AI for telecom. So if you want to have a better channel estimation, or you want to have a better resource utilization, or maybe anomaly detection in the telecom network, in those cases, AI for telecom can be one of the work group which will work on it. AI on telecom is building next generation AI driven application which can be built on the telecom infrastructure and can generate new revenue streams for the operator. So these are the applications which are going to be newer application, and these are the application will be built on the existing telecom infrastructure and generating more revenue streams for the operator. AI and telecom is going to be the way of utilizing infrastructure. So we all know that both telecom and AI requires a very huge infrastructure. And building a separate infrastructure just for AI may not make sense. So what we can do is we can actually explore the concurrent use of converged computer and communication infrastructure for telecom and AI Gen AI workload. So whenever telecom is not using it, AI can use this infrastructure. Whenever telecom is using it, the AI may use a very little infrastructure. So we can actually make sure that the AI usage, the AI and Gen AI workloads are using the same infrastructure, but not at the same time. So sharing the underlying infrastructure between AI and telecom will make more sense if we really want to make it a success. If somebody wants to make a AI as a standalone system supporting telecom network, it may not be a great idea. It may not be very useful for the future growth of the network. Now, machine learnings have various different types, right? So even though I'm not really talking about it, we generally say supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, self-supervised learning. Just to give an idea, supervised learning is something which works with something called as label, which will have some kind of classified data where we have clearly defined input and outputs. The unsupervised learning works with the data without labels. So you don't know what is input, what is output. The machine learning model itself will make something out of it. The reinforcement learning helps you to have a learning agent in a learning environment where the agent will take some actions, and based on his actions, he is going to get some rewards or going to get some kind of penalties. So basically, based on the actions, the agent is going to take some rewards and penalties, and the idea for this agent is going to be maximizing those rewards. So supervised learning can be related to network traffic classification or maybe signal strength prediction. For unsupervised learning, it can be network anomaly detection or maybe customer segmentation. For reinforcement learning, it can be self-organizing network or maybe some kind of dynamic spectrum allocation. So it's possible to implement multiple one particular use case with multiple different techniques. So you can try to do it with the supervised learning, you can try to do it, not everything, but some of the use cases can be actually dealt with the multiple different machine learning types as well, right? Nowadays we also hear a lot of information related to LLMs and generative AI. LLM and generative AI, large language models and generative AI. However, a large language model is a model which is trained on a very large data set. For example, ChatGPT, they are typically trained on 175 billion tokens. This is the kind of mammoth size they've got. Now, if I use ChatGPT for a telecom related application, is it going to be useful? It may or may not be useful. It may or may not be useful. Now, in this case, what we need to do is either we need to fine tune the existing LLM models with the telecom specific data, or we need to build a new model specifically trained on telecom data. And in this case, we call this model as a LTM or large telecom model. Large telecom model. These large telecom models refers to large scale AI models specifically designed or adapted for the telecommunication industry. Now, what we are doing is either we are using existing LLM and fine tune them with the telecom specific data or create a LTM from scratch. What it is going to do is training on the telecom specific data, bringing in advanced telecom capability in the use cases, integrating with the telecom ecosystem, and doing NLP and generative AI for telecoms. These are going to be some of the use cases of LTM or large telecom models. For example, some of the OEMs, so let us take an example here. Like some of the OEM, for example, say Nokia, right? Nokia have a very big support team. And there are hundreds of, not even hundreds, thousands or hundred thousands of network functions which are managed by those teams on daily basis. What they can do is they can build a support function. They can build a support app. They can build a support app. And this support app can be trained on lot of product documentation, lot of change management, and lot of GFR, generic failure reports. And by getting all this information, whenever some problems are happening in the network, they can actually check with the support app before they take any actions. So I can have a support app application which can be trained on Nokia specific information, and then it can help. Then it can help, right? Then it can help you to give some answers related to specific problems which are happening in the network. This can be one of the use case related to the network management, right? So there can be many more use cases like that, right? So I'm actually training the large language models or fine tuning them based on some kind of telecom specific data. Now, these use cases can be in variety of different domains. It can be related to network planning, where we do intelligent cell design, dynamic resource allocation, network intelligence, improved cell coverage and capacities, traffic prediction, right? It can be related to network optimization, related to interference estimation, self-healing network, dynamic self-configuration. It can be related to network O&M, where we talk about monitoring of network APIs, talk about automatic ticketing system, failure detection, root cause analysis, and it can be also related to QoE improvement, quality of experience improvement. So in this case, AI-based congestion detection and dynamic traffic rerouting, predictive QoE monitoring and automated network adjustments, machine learning for real-time interference mitigation. So these can be some of the use cases, related to quality of experience. And in addition to that, we can also bring in lot of end user applications. For example, telecom chatbot we can create. We can actually create lot of different applications which can be related to AR, VR, smart cities, IoT devices, because these IoT devices are going to big in numbers, sending lot of different data, different types. So for example, use cases like smart cities, intelligent transportation system, public safety systems, they can all be implemented by using AI ML for the end user applications, right? These are some of the end user application, not restricted to telecom, but even beyond that. But at the core of most of these application, even these things can work even without AI ML as well, but AI ML, without wireless network as well. But wireless is going to give a lot of power to many of these use cases, right? Now, the next section, we are going to talk about if we are actually implementing machine learning and deep learning in the telecom network, how do we really do step by step? A very quick overview on the step by step implementation of it, right? But before we do it, I will pause for a minute and take up any questions if you have. So do we have any questions before we continue with our discussion? Any questions? Please drop your questions in the chat box. Okay, so Anand says, is it deployed in private network? Anand, first of all, let me tell you, the private network, which is pretty overhyped in 5G, is nothing but a network, right? So it's just a different deployment, which is confined in a given location or a given customer. So network is a network, whether it is private or public, of course, done it at a different scale. Now, whether it is internet access or without internet access, you need to understand that if you are creating a private network, you have to create a data network, because the 4G and 5G network are not designed to give you any services. The application has to come from data network. Applications has to come from data network, right? Now, if you are building a private network, you are actually building that private network to host one of the application in the form of data network. Now, can you deploy AI ML algorithms in the private network? The answer is yes. You can deploy it on the radio access network. You can deploy it in the core network, and you can also deploy it on the application level as well, right? So all these things can be done. You can also build some of these applications even as like edge applications. So you can also deploy them as a, as application as well. Shahir says, what are the different O&M use cases using AIML? So, Sahir, network fault prediction, anomaly detection, self-performance, self-configuration, All these things are related to O&M related use cases. Now, EKAMISU. Okay, I'm not sure. I think it is something from Ericsson. I used to have these kind of names when I used to work with Ericsson. Right. So, can you give an example of a new revenue stream which can be utilized using AI for by operator? Let us take an example. Let's say quality of experience. Quality of experience, where I can actually predict the quality of experience for a given user. In this case, what I can do is, because I'm having a way of controlling the experience of the end user, I can have some specific tariff plans which can be like gold customer, silver customer, or bronze customers according to their capabilities. In addition to that, what else I can do is I can try to use my network as a AI ML engine and can get access of this data to the third party services. So what we were talking about as NWDAF earlier, network data analytics function, which can create some analytics in the network, and those analytics can be shared with the third party services in a controlled manner. Right. So all these things can help operator all these things can help the operator to generate more revenue streams from their third party vendors or from their enterprise customer. Okay, so these are some of the different use cases you can do it for the new revenue streams. There is another question from Ramnivas Mawar, which says how we can predict traffic patterns with the use of AI/ML. Now, if you see this, we always have a possibility by looking at the past patterns and the past data. We can always predict the traffic patterns. It may or may not be correct. So prediction may not be right. That's what we need. Prediction is a prediction, right? So what you predict for today, what you predict for tomorrow may not be correct, right? But network traffic prediction, throughput prediction, QoE predictions are one of the important use cases of AI/ML. Any other questions before we continue? Any other questions? Oh, so if Ramnivas is saying how we can do it, that's not something what we can discuss it. So I look at the past pattern, I look at the historical data, and based on that, I'm going to predict the traffic for the future networks. Like maybe tomorrow, maybe over the weekends, I can predict it, but it may or may not happen. Right. Any other questions? Right. Now, let us look at, and in this discussion, the next discussion what we are having. Okay. So the next discussion what we are having here is may not be same for all the different mechanism, but it's just a very, very high level information how these things happening in the network. So let us try to understand it. 1 second. Okay. First of all, why we need to use machine learning and deep learning in telecom? Machine learning, the telecom networks generates a massive amount of data, and it is going to go to the next level in the future networks like 6G, which is going to be AI native networks. It is going to need a lot of intelligent automation to reduce the cost of the network management. It can enhance the customer experience and reduce the churn of the network, and a lot of different innovations like self-organizing, optimizing network or self-organizing network. As I mentioned, self-organizing network is not a new concept. This has been into the network for many, many years. We are just trying to enhance it for the 5G and 6G network. Now, even before you get started with it, the first thing, there is no single answer to all the problems. So first of all, you have to know your problem, and then only you will be able to find an answer to that problem or solution to that problem. First of all, even before you start looking at MLDL or something, first you need to know what problem you want to solve. So you need to list your use case. What is the use case? I'm trying to sort it out with this particular implementation. It can be related to customer churn, it can be related to network anomaly detection, fraud detection, related to traffic forecasting, QoS optimization, call drop prediction, or 4G, 5G, 6G network slice or optimization. These can be some of the example use cases, but there can be 100 more use cases. Right. Now, collecting the data and understanding the data. Telecom data, you can get it from the various CDRs. call detail records. You can get it from PCAP logs, from network KPIs and counters, billing in the CRM system, IoT devices, or maybe a lot of OSS BS system. So very first thing what you are going to get is collect this data and understand this data. Understand the data schemes, how this data is organized, what are the key attributes in this particular data and how they are relevant to this particular problem. These are the things what you have to collect, collect the data and understand it. After doing this, after doing this, we have to do the data pre-processing or data wrangling. Where what we do is we actually handle the missing values and also the outliers. We normalize the features and standardize the features. We encode the categorical values, convert the categorical value into the numerical values, and create some kind of time-based feature, perform sessionization for logs or the PCAP data. So which type of logs are used for which particular specific sessions, that because in one particular PCAP file, I can have the logs for 100 users, right? So 100 users are doing UE registration, 100 users are doing PDU session. So what we did need to do is we need to bring them together with a single session, and then only they'll make sense, right? Now, for doing this, we will be doing all these hands-on by using pandas, numpy, and scikit-learn, etc. And we will not be using Spark, but that can be done for more real-world deployment. So we will be having the detailed discussion around pandas, numpy, scikit-learn, etc. for doing the data pre-processing. After that, you also do exploratory data analysis, where we look at the correlation, distribution, and anomalies in the data. We look at the time series behavior, class imbalance, etc. And for that, we use some visualization tools like Matplotlib, Seaborn, or Plotly, etc. And then we choose the right model. However, it is very difficult to predict at the early stage what is going to be the right model for you. But some use cases may be good enough just for them with the machine learning. Some of them may need the deep learning expertise. For machine learning, I may use classification, logistic regression, random forest, XGBoost, etc., regression, linear regression, clustering, k-means, transformer. So these are the different architecture for supervised, unsupervised, and reinforcement learning. For deep learning, we have ANN, CNN, RNN, LSTM, autoencoder, transformers, which is one of the basic building blocks for generative AI platforms. Right. After understanding the model, we are going to split our data into train and test data. Some of the data we are going to use for training, some of the data we are going to use for test, and then use matrices like accuracy, F1 score, ROC, AUC, MSC, depending on what type of task. So if it is a classification problem, the different metrics will be used. If it is a the continuous values, it may be different type of accuracy. So we may use MSC, MAI, RMSC, etc. for the different type of use cases. Perform hyperparameter tuning. How do we really tune these hyperparameter, and also doing the cross validation of these different parameters. We use scikit-learn, TensorFlow, Keras, PyTorch, etc. for doing all these things. Then comes the model explainability, looking at whether tomorrow if you have to explain this model to telecom regulator and stakeholders, so you need to look why we were able to achieve this target, how we did it, and what we did it. And that is also very important if you have to deploy these AI models at scale, right? Now, finally, once you are able to test it, you are able to train the model, you are able to test the model, how you are going to deploy this model in the real world, whether it is related to OSS, BSS, radio network, core network, doing it on edge deployment. So we will be talking about, like Streamlit, we will be talking about, like some kind of tools, how you can deploy it in the real world deployment related to the specific use cases. And finally, after deploying it, keep on collecting the monitoring, keep on monitoring the model, and keep on doing the training and retraining over the period of time, right? And finally, this is not one-time activity. This is going to be a continuous activity where we have to keep on learning and keep on deploying the next level generation of all these things in the real world. Now, how do we do it? Typically, there are a variety of different tools which can be used. But generally, we have options like Kaggle, Google Colab, Notebook, etc. So if I talk about Kaggle, right, so we are going to build most of these use cases on the Kaggle, where we talk about path loss, site dimensioning, Bangalore, talking about transform for telecom log anomaly, RNN for telecom CDR analysis, reinforcement learning for the self-organizing network. But some of these use cases, we are also going to build on top of Google Colab as well. So we will use either Kaggle or Google Colab. If you want to use any other tools like PyCharm or Jupyter Notebook, etc., that also you can use. But in our case, we will be using mostly the Kaggle and the Google Colab for our practical use cases. Right. So with this, let me see if I have anything else to discuss. Okay. So that's a quick introduction about the AI ML in telecom. And now I'm going to talk about the detail of the course what we are starting next week. But even before that, if you have any questions, do let me know. I can take up those questions and then we can talk about the course what I'm talking. Will you explain all these talks from zero to advanced level? Ramnivash, if you see, I will be starting from zero uh, to a level where we are able to build all these use cases and train and test all these use cases. I will not say advanced, because advanced goes at a much larger scale, where we're talking about AI agents, MCP, etc. So that's not really the thing what we are building here. But yes, for telecom specific use cases, we are going to talk about all these things in our course. Do we going to learn how to make models for different predictions? Yes. So there are multiple use cases. It's not about building the models or making the models, using the models and training those models based on the data set, based on the use cases what we have got. So we are not going to build these models from scratch. There are a lot of statistics, lot of mathematics involved. We are not going to get into it. Just to use these models, train those models, test those models, and use it for our use case. Is any coding experiences needed? If you have any prior experience with the coding, it is good. If it is not, then also it is fine, because we will be starting with the fundamentals of Python. We are going to use majorly the Python for all these implementations. So we will have either 1 or 2 sessions. And in addition to because 1 or 2 classes may not be sufficient to do everything, I will be sharing the complete Python course with you, that you have to do it at your pace. We will not be cover everything related to Python, but we will be starting with the fundamentals of Python, and then we will be building those things with the Python itself. Any other questions? Okay, so Venkata says, what is the difference between machine learning and deep learning? So machine learning, we typically have where we talk about some specific models which are built related to supervised, unsupervised, and the reinforcement learning. The deep learning is something where we actually get a lot of intervention from the neural network. So we typically call this as a ANN, artificial neural network, and they are further classified into various different categories. So these are multiple layers of neurons which are acting like the neural network, and that's where we actually do the deep learning. So multiple layers of neurons with non-linear inputs, lot of activation functions, and n number of other details, which actually gets into the deep learning. It's a little more complex, little more mathematics involved into that. Right. Any other questions before we talk about the course? Okay. And if you are not really interested in the course, please feel free to drop out and maybe drop me a message at a later stage if you wish to. This is going to be a AI/ML course starting next week, Saturday, going to be on Saturdays and Sunday morning from 12 to 1 IST. If you are from different time zone, before you join the course, please look at the convenience of yourself with the time zone. Time zone is IST, Indian Standard Time, which is going to be GMT plus 5:30. So before you join the course, look at the convenience of the time, so that you are not really getting lot of inconvenience because of the timing, etc. Right. This is going to be 8 weeks course, where we will have 16 plus sessions, 2 sessions per week, Saturdays and Sunday, and every session is going to be 1 hour each. Starting date, which is mentioned today, which was more of an introduction, and we will be starting this session next week, 12 p.m. to 1 p.m. IST. Now, somebody asked this question, how we are going to start it. Initially, we'll start with 1 or 2 sessions of Python. We will talk about Python basics for AI, ML, and telecom. The session 2 will be more about pandas for telecom data processing. Session 3, we will be talking about machine learning fundamentals, supervised and supervised reinforcement learning, and then we will be doing some hands-on with the scikit-learn, right? In session 5 and 6, we will be talking about deep learning basics, where we'll talk about ANN, CNN, RNN, etc. Where we'll talk about what are neural networks, what is CNN, RNN, and what are the different use cases related to CNN, RNN, LSTM, etc. In session 7, we will be looking at some use cases related to anomaly detection and fraud prevention. Session 8, we are going to talk about AI ML for network prediction, traffic prediction and optimization. Session 9, we will be talking about NLP, natural language processing in telecom. How do we do the tokenization, lemmatization, etc. Session 10 and 11, we will be talking about model deployment and edge AI in telecom. Session 12, we will be talking about AI for self-optimizing network. Session 13 and 14, we will be talking about generative AI. With that, we will be also talking about generative AI in telecom using LangChain and RAG. Session 15 and 16, future of AI in telecom and industry trends. What is AI is going to be for 6G and beyond, quantum computing and AI in telecom. And finally, we will be wrapping up with the question and answers. What you're going to get is telecom data sets for machine learning and deep learning projects, guided hands-on lab for more than 10 use cases, code notebooks and implementation guides, reference materials, session recording for 6 months, and the course handouts. So all the things, all the slides that we cover, it will be given to you as a handout. Okay, this is more or less the similar thing, right? The course fee, originally it was 25,000, but now we are offering it in 20,000 plus taxes, which is going to be approximately 18% GST to be paid after this class. Right? If you're interested, if you're not happy with the discussion, if you're not happy with the course, you can actually get it refunded within the 10 days of delivery, right? But even before you do it, just be sure that you are able to get answer to all your question and then only enroll for the course. If you are joining with 2 or more people, you're going to get 10% discount. If you're joining both the courses, this course and the 5G core course, then also you are eligible for a 10% discount. Please note, this fee which is mentioned here will have additional taxes involved with it. Yeah, right. So that's a quick introduction about the course. If you have any questions, please feel free to ask those questions in the chat box, or you can raise your hand and then ask your questions. So any questions from anyone before we